Hello and welcome back. This is Mr. Powers, and we are continuing on our quick introduction into statistics. The example we're on right now is a voluntary response sample. We're just going to talk about voluntary response a little bit. A voluntary response sample or self-selected sample is one in which the respondents themselves decide whether to be included. So it's like where he's like, I want to talk. I want things to be known about me. And so you say, hey, here, this is stuff about me. Use it. That's a voluntary response. The following types of polls are common examples of voluntary response samples. By their very nature, all are seriously flawed because it's not random. We talked about that in the last video. We love random. Voluntary response is not random at all because you're going to hit just those people who are like, yeah, I want to volunteer. All right? There's a certain kind of person. That person may be those kinds of people might have certain things in common with each other and be different from other people. So we don't know if our data is going to be skewed by that. The more random, the less those kinds of things might come up. By their very nature, all are seriously flawed because we should not make conclusions about a population on the basis of samples with a strong possibility of bias. We want data that means something. Bias, if we don't know, we can't make an inference about a population if we're only talking about people who voluntarily respond. That's not the average person. That's not representing a large group. So it's not going to be helpful. Internet polls in which people online can decide whether to respond. There you go. Mail-in polls in which people can decide whether to reply. Telephone call-in polls in which newspaper, radio, or television announcements ask that you voluntarily call a special number to register your opinion. None of these are good. Internet polls, the websites I go to aren't the same websites you guys might go to. So we're not going to see the same polls. It's not going to be very useful data. It might be fun to talk about, but it's not good. So the ABC television show Nightline asked viewers to call with their opinion about whether the United Nations headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of 186,000 respondents said that the United Nations should be moved out of the United States. In a separate and independent survey, 500 respondents were randomly selected and surveyed. Ooh, we got a randomness. And 38% of this group wanted the United Nations to move out of the United States. So which one is going to be better? The one that's random. That's going to represent the general population a lot better. Okay. The two polls produced dramatically different results, even though the Nightline poll involved 186,000, so they had a lot of respondents. The much smaller poll of 500 randomly selected respondents is more likely to provide better results because of the far superior sampling method. Again, we're going to go into that much more later. Just a taste of what's to come. So we got that out of the way. Now we're on analyze. So if we go back to this fun little table, we finished the prepare stuff. Now we're going to go through, talk a little bit about analyze and. All right, so on to analyze. After completing our preparation by considering the context, source, and sampling method, we can begin to analyze the data. So we make sure we got our data the right way, an honest way, in a way that's actually useful, not misleading. Now we can analyze it. Graphing is a great way to do it. Graph and explore. An analysis should begin with appropriate graphs and explorations of the data. apply statistical methods. So a good statistical analysis does not require strong computational skills. There may be some complicated computations, but technology can help with that a great deal. And at the end of the day, it's going to be a lot faster to use technology. A good statistical analysis does require using common sense and paying careful attention to sound statistical methods, things we are going to be going over. And then we got our conclusion step. We got to make those conclusions. So the final step in our, hold on here. Oh, there we go. Don't know why I try. The final step in our statistical process involves conclusions, and we should develop an ability to distinguish between statistical significance and practical significance. All right, so we got these two things here: statistical significance and practical significance. I said it before. We're going to care more about the first one than the second. But here is an example of each one. We'll compare. So statistical significance, that is achieved in a study if the likelihood of an event occurring by chance is 5% or less. 5% or less. That's kind of our magic number there. So getting 98 girls and 100 random births, that's highly unlikely. You should be around 50 out of 100, about half. That is almost all of them. So something like that is not likely to happen. Therefore, it is statistically significant because such an extreme outcome is not likely to result from random chance. And then getting 52 girls and 100 births, that is about half. That is not statistically significant at all because it's very likely that would happen. So it's not going to, it's like, yeah, sure. We'd expect that to happen. So now what? Okay. Now, practical significance is another thing. It is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So let's look at an example. This is a fine example. In a trial of weight loss programs, 21 subjects on the Atkins program lost an average of 2.1 kilograms or 4.6 pounds after a year. So a whole year on this diet, they lost less than 5 pounds. Okay, but now if they're able to make that claim, there was statistical significance. The results show that loss is statistically significant. They were able to say with confidence that, hey, yeah, you're on this diet for a year, you're going to lose a little less than 5 pounds. So we're able to make that statement, then yeah, that doesn't happen by itself. So it must be because of the diet. But everybody's thinking it, like 5 pounds for that thing after a year, maybe there's something better, right? So, however, many dieters believe that after following this diet for a year, a loss of only 2.1 kilograms is not worth the time, cost, and effort. So that for these people, this diet does not have practical significance. It's not practical. It doesn't make sense. Why am I going to bother with it for 5 pounds? Most people wanting to lose weight, like myself, probably be happier with, let me see. I'd be happy with 15. I mean, 10 would be all right, I guess. I'm not terrible, but 20 would be, 20 would be really good. I'd probably be good with 15. Anyway, moving on. Analyzing data. Oh, We got what did we get? Analyzing data. Potential pitfalls. Okay, and again, I'm glossing over this because we're going to go over this more as we go. So anyway, misleading conclusions. When forming a conclusion based on a statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. You always want to be clear when you communicate. You want to be able to make convincing arguments. A lot of stats is making convincing arguments. Maybe you have a boss. They want to know if mailing out mailers to these kinds of people is different than mailing it to these people, or how often should we mail them out? Doesn't make a difference. You want to present data in a nice, easy way. You want your boss to understand it. You want to be useful. Sample data reported instead of measured. When collecting data from people, it is better to take measurements yourself instead of asking subjects to report results. You got to make sure your data is accurate. It's good data. Loaded questions. If a survey results are not worded carefully, the results of a study can be misleading. And there are example after example after example of that. That happens all the time. And you got to wonder, is that an accident? Order of questions. Sometimes survey questions are unintentionally loaded by the order of the items being considered. So the order in which you present things will also affect it sometimes. All right, hang in there. Almost done. Analyzing data. Potential pitfalls. We talked about it. Non-response. I'm one of those. I'm just disagreeable. It's in my nature. I'm also private. And I also don't really trust a lot of the polling agencies or have respect for them. So I don't participate. A non-response occurs when someone either refuses to respond or is unavailable. Low response rates. If a survey has low response rate, the reliability of the results decreases. In addition to having a smaller sample size, there is an increased likelihood of having a bias among those who do respond. And then percentages. Some studies cite misleading percentages. Note that 100% of some quantity is all of it, but if there are references made to percentages that exceed 100%, such references are often not justified. It's nonsense. Can't have more than 100%. I like the ones where I had to give percents once for some data after teaching a summer class at Fresno State. It was Summer Bridge, and they wanted all this data. And there was one where it's like, there was a 50% change. So what was that? That was like, oh, there were 2 students, and then there were 3. A difference of 1 student. But when you say, hey, there was a 50% increase, oh, that sounds a lot better. So you can be misleading with those really easily. There you go, guys. That concludes our section 1.1 from our book. So without further ado, hope you enjoyed this. Have fun doing math. See you next time.